These are some experiments and pitfalls found when trying to interface and synchronize a CV-based synthesizer to a multi-track recorder. I'm using a solar ambient synth, which has no MIDI connections, just CV and gate, and an MPC recorder, which has both MIDI and CV. This is my first attempt at using CV outside a modular synth. I normally use MIDI for interfacing, so this is just for interest. There may well be better ways. The requirement was to develop a live improvisation piece made on the Solar a few months ago. The link is in the description, but it was too hard to play consistently without mistakes. I just didn't have enough hands, or more likely skill. Here's a breakdown of the Solar patch to show which modules are used. Now, it may not sound right as I've been messing with the controls, but you get the idea. The tempo is defined by the pulse generator, which drives a 5-step sequence with outputs on beats 1 and 3. These trigger drone 5 to give a background heartbeat sound, and I think it's the slow speed and odd timing of this which contribute to my inability to play it live. That's my excuse. The touch keyboard plays the melody, its CV and gate goes to VCO-A. No patch leads are needed as these are normaled connections. The drone buttons are used to trigger ad hoc bass and filler sounds. All sounds go through the built-in mixer, then to the filter, which is modulated by a sample and hold module, which samples VCO-B, whose audio output is turned down, and is clocked by an LFO. And finally through the Infinity effects card. Now, the first idea was to overdub the audio from each module onto separate tracks using multiple recording passes. And this meant locking the song tempo to the recorder so it would be in sync for each pass. And this was the first gotcha. The MPC gates generate 5 volts, but the step sequencer needs at least 5.6 volts to trigger. I found this by experiment, but apparently it's not consistent across machines. Other users have found they need even higher voltages. The level converters are usually available on traditional modular synths. I don't have one handy, but this Kenton Pro Solo MIDI to CV converter has a convenient auxiliary output which can generate gate voltages at any level from incoming MIDI clock messages. So to configure the MPC to generate these, go to Preferences, MIDI Sync, and turn on Sync for the output port connected to the Pro Solo. Mine's plugged into MPC-B. Then scroll down to Sync Send and set Send to MIDI Clock. Don't confuse this with MIDI Timecode, or MTC, as this is a completely different type of clock message. And that's all that's needed for now. No data, it can just be a blank project. And when you press play from start, it will generate MIDI clocks. I'll turn on sequence loop so the clocks run forever, otherwise they'll stop at the end of the sequence. On the Pro Solo, config option 41 sets the clock division factor, which defines how many MIDI clocks are needed to generate a gate pulse. The MIDI spec says there are 24 clocks per quarter note, so I've set the divider to this value. The config option 21 defines the minimum voltage on the aux1 output, so set this to 0, and option 22 defines the maximum voltage. The displayed value appears to be in 100 millivolt units, so I'll set this to 10 for now, which is 1 volt. On the MPC, press play from start. The scope confirms the gate pulses are 1 volt, and as you'd expect, there's nothing happening with the solar sequencer. Let's try 40, which is 4 volts. The sequencer starts generating gates for the drone, but it doesn't sound right, and the lights are not moving, so it's not triggering properly. Let's increase to 50, 5 volts. Still no good. Now to 60, 6 volts. And the lights are now moving, and it sounds correct. You can press and hold the select button to store this value permanently. So all well and good, I started to assemble audio recordings of each module in turn, but as I was doing this, I realised if I recorded raw CV and gate information instead, I would have much more control over the song arrangement. I could edit the pitch and timing in the note editor, as opposed to sliding audio tracks around, and if these could be played back to control the solar, it would generate audio for the completed song, mostly hands-free, but still leaving scope for live performance tweaking as needed. The drones are fairly easy, although I was unable to record the button presses as their outputs don't seem to be accessible. But they're only used occasionally within the song, so I can skip the recording phase and just manually insert triggers into CV tracks on the MPC. Here's an example. Create a CV track, turn off CV as we're not using pitch, confirm the gate is set to the output port connected to the solar drone. There are 8 available. I'll use CV2 for this. So this is connected to Drone 1's gate input. The drone gate thresholds are lower than the sequencer. Mine only need 4.7 volts, so this time the MPC gate voltage is sufficient to trigger them directly. I then realised the timing clock routing was unnecessary. It was only used to drive the sequencer, which in turn drives drone 5, so now I know the MPC 5V gates can trigger the drones. Why not bypass the sequencer and drive it directly from a 5-step pattern manually inserted into a CV track? Here's an example. Create a CV track as before. I'll reuse CV2 for the gate, connect this to Drone 5's gate input. Now this is the latest version 3 firmware for the MPC, and it infamously lacks time signature control, so I'll just bodge something for now. I'll leave it set to 4/4 time and use quarter notes to mimic each step of the solar sequencer. Insert gates on beats 1 and 3, and copy this 5-beat pattern as required, say 16 times. Press play and we get the heartbeat. Okay, how about the melody? Well, this is not so easy if I want to record notes directly from the touch keyboard. I could just record MIDI from an external keyboard, but this would miss out on the tactile advantages of the touch version on the Solar, so I'm forced to use its CV and gate outputs. But, gotcha number 2, the keyboard gate outputs a whopping 10 volts. I've not found a safe upper limit in the MPC spec, but seeing as how it only generates 5 volts, I was reluctant to feed 10 volts into it. Luckily, another Kenton device came to the rescue. It's the opposite of the Pro Solo and converts CV to MIDI. This means the MPC can record the melody onto a MIDI track. Here's a quick demo. Create a MIDI track. Set the MIDI input port to the socket connected to the converter. Mine's on MPC-2. Arm the track for recording. Turn off timing correct, or quantize, if you want to capture those nice slides from the touch keys. Set the sequence length and tempo as required. Switch to arranger view and start recording. And you can see the events coming in as they're recorded. Now we come to gotcha number 3 when you try and play it back. Now with the live performance, the Solar keyboard drives VCO-A using CV and gate signals. But you guessed it, the Solar VCOs need a gate of at least 6.7 volts to trigger them, so the MPC gate is obviously too low. But why not switch to MIDI playback into the Pro Solo converter and use its CV and gate outputs instead? Well, it turns out the gate voltage is not continuously adjustable like the AUX1 output. It has 2 possible config settings, 5 volts or 15 volts. What a minefield. As with the MPC, I've not found a definitive safe upper limit in the Solar spec. The highest value mentioned is 12 volts, so I'm reluctant to use 15. But luckily, reducing a level is a lot easier than increasing it. Here's my crude example of an inline voltage divider using a 10K trim pot. Here's how to set up the Pro Solo. Config option 16 defines the gate type, which offers combinations of short trigger versus gate and 5 volts versus 15. So set this to gate 15. So the special cable can drop this to 10 volts. Connect the other end to VCO-A's gate input and connect the CV output to VCO-A's 1 volt per octave input for the pitch. On the MPC, set the track output to the port which connects to the Pro Solo, MPC-B in my case. Press play and you'll hear the melody. And I can still do live tweaks, for example by patching the pressure output from the keyboard to the VCA. Okay, that's it. Phew. All the pieces of the jigsaw are now in place and I can get on with developing that song.